We now begin the unit on functions. I'm going to start with something that's not in your practice set, but it's an important idea because it's going to come up a fair bit later. The idea between what is a relation and what is a function. So starting with the definition of relations, I guess you could say that all graphs are relations. I'm sure there are some exceptions, but for our purposes, let's consider all graphs relations because they relate x and y values visually. So with that definition in mind, it's safe to say that both of these graphs are relations. One of the two is a function, and we're going to call on something called the vertical line test to check this. And what the vertical line test does is says that if you have a vertical line, and as you move that vertical line through your graph, you want to make sure that it only ever touches the graph, the green line, in one place. And we can see that it does, right? It's only touching that green line in one place with each of those vertical lines. With the second graph here, you'll see we run into trouble. This is a graph of a circle, which we cover in more detail later. But as you notice, when I draw vertical lines through that green graph down there, the red vertical line touches the green line twice, so more than once, and that's the idea. So this one up on top is a function as well as a relation, right? That's REL for relation, and the bottom one is only a relation, so it's not a function. Functions have to pass the vertical line test. Another way to look at that, which might be a more useful definition, I guess, is that at x equals 1, for example, there's only one output. If x is our input and y is our output, well, if x is equal to 1, y is equal to 1 in this case, if I assume that this is a y equals x squared parabola, right? Down here, however, if x equals 1, y has two different values. It has one at positive something and one at negative something. So once again, this is a way to tell a function from a relation. The top one is a function, and all graphs are relations. All right, the next thing we look at is substitution. Functions might seem a little strange, but we've already worked with them. In the last unit, we were looking for y equals mx plus b, right? And we would come up with lines like y equals x plus 15, for example, was one we looked at. And you can interchangeably use function notation. So function notation is another way to understand or write equations. Okay, and there are certain properties you need to understand about that. And those properties are that is the function's name. If you can read my writing, it's going to be difficult. This is the function's input right there, and this is what the function does. So it's important that a function has a name, so you can call more than one of them. You can identify different functions within the same situation. It's important that you can send an input to the function. And then it's important that you can compute whatever that function does and get a result. Okay, so which is very much just like what we did with y equals x plus 15. Well, f of x equals x plus 15 is going to give you the same result. Functions just have some different properties versus the equations we looked at before. We discussed that a lot more in class. So with that said, let's look at how functions work. All right, so we've done this already. You've done substitution. You're going to find this pretty easy once you understand the different notation. One common mistake is thinking of, oh, I don't want the erase there, I want that. One common mistake is to think of a function as the letter f, that's what that is in case there's any confusion, and the letter x. This is not f multiplied by x, all right? This is the function's name, which is f, and once again, this is the function's input, which is going to be substituted wherever you see an x value. So So let's look at an example like f of x is equal to x squared plus 2x. We are asked to substitute -2 into the function named f. Okay, well, let's do that. So the way that works is we put -2 inside a bracket. It's really important to substitute in brackets. What you'll notice here is if I don't have a bracket here, I'm going to think that the result is -4, especially if I use a calculator. But when I substitute using brackets, I'll see that the correct response when -2, right, because that was our input, when -2 is squared, the result's going to be +4. And we have to make sure we substitute the number -2 in wherever we have x value. So you notice it's been substituted twice over here. Let's continue with our solution. So f of -2, -2 squared, we said -2 times -2, +4. And over here we have +2 times -2, -4. And overall, the result of this will be 0. The last type of function substitution that you might see that's different is what happens when we try to substitute some additional variables back in. Well, this is possible to do. Functions are literal sets of instructions. It's just really important that you follow the instructions exactly as they're given, and you should come up with the right result. So we have a new function named r. Its input is x, and over here what it does is it squares any x values. The input, this is what's a bit different this time, is n plus 1. All right, so if it's n plus 1, well, we're following the same instructions as above, that whatever the input is, we need to put that in wherever the value is that's in the original, right? So what we're doing is we're subbing in n plus 1 into x. We're just making x n plus 1 because that was the function's input. Okay, and the instructions were to square that. So whatever the input is, we were supposed to square it. So we'll do that now. And n plus 1 squared really means n plus 1 times n plus 1. And as we calculate this, n times n squared, and that was the first one. N times +1 is plus 1n. 1 times n is plus 1n, and 1 times 1 is 1. When we collect our like terms in the middle, we get n squared plus 2n plus 1, and that's the result. So that should be as complicated as an example as we need to look at for function substitution. That's the definition and introduction to functions and relations.